Okay, let's begin our next lesson of subtracting vectors. Okay, so recall that there are two methods that we went over on how to add vectors. Okay, and so one of them, if I have two vectors, let's say one that goes up like this, let's call that U, and another that goes like this, let's call that V. If we draw them head to tail and close the triangle, the part where we close the triangle is called the resultant vector. Okay, so something along the lines of this. And again, you draw them head to tail. And then the resultant vector always goes from the starting point to the end point. Okay, and one thing that's noteworthy, so this is R, this is U, and this is V, is that if you were to give the angle or the direction of this resultant, you would not only just find that angle there, you always need to find it with respect to either a bearing angle, okay, which is always measured from the north, okay, or a quadrant bearing. Okay, so a quadrant bearing would be again from the north, but then this time you go either towards the east or towards the west. But in this case, this is the angle you would report on about the direction for the resultant bearing. So you'd have to find this angle in here, okay, and then also add this angle here to it as well. Okay? Now, there was also another method, okay, and it was called using the tail-to-tail method, which involved creating essentially a parallelogram. So again, if you have these same vectors, okay, U and V, okay, it was drawing them tail to tail and creating a parallelogram. So it would end up looking something like this. And then the resultant is right there. Okay? So you still end up getting that same triangle that I had drawn up here. Okay? But it's just another method that you can do it tail to tail. It can still work as long as you create a parallelogram. Now, given that the vector U is being subtracted with the vector V, or vector V is being subtracted from vector U, here's how you actually subtract vectors, okay? What you're going to do is you're going to leave your first vector, so U, you're just going to leave it as is, as a U vector. But instead of subtracting V, what you're going to do is add the negative version of the vector. And we know how to draw a negative vector. So, and in case you don't remember, we've been through this. But if you have a vector going in this direction, let's call it U, the negative corresponding vector here would be going in the exact same in the exact same magnitude, just in the opposite direction. And so that would be called the negative U vector. Okay? So to subtract vectors, we're going to add the negative vector for the second vector in our subtraction equation. Okay? All right, so let's take a look how this works just with lines going east and west. Okay? All right, so we have this vector here, subtract the other, and let's call this U, let's call this V, that's my U. I'm going to add these vectors, and with my second vector, I'm just going to draw it in the opposite direction. So this will be known as my negative V. Okay, so my resultant, it says the example is to draw the resultant vector, is I'm going to be left, if I overlay these on top of each other, I'll just be left with a small resultant going in this direction. Okay, that's known as my resultant. Now, what about here? So here we're going to draw, same thing. We are going to draw the first vector the exact same. And let's call that my u. But now I'm going to add the opposite direction for the second vector. So my resultant is just going to be adding these head to tail. So drawing one big line that probably looks something about that size. This would be my resultant. Okay, so simple enough concept. All right, let's head down here. There's a question like this in your homework, and so I wanted to go over this because I knew that there'd probably be quite a few questions regarding it. So I'm just going to label this A, B, C, D, and E. And what we're going to do is name a vector equivalent to each expression. So a vector that essentially is the resultant, that's what they're talking about, is finding the resultant of each expression. So AB minus AE. Now, minus AE, okay, we want to add, so we want to take AB and add negative AE. All right, so we're going to actually be going, instead of going in the AE direction, we're actually going to go in the opposite direction here. It's going to look like this. Okay. Now, we want to draw this head to tail, right? And we want to take our first vector that was in our equation here, or expression, AB, and then draw this vector head to tail. So I'm going to draw AE somewhere here. Okay? So the resultant would actually be, that's E, would actually be whatever this line is right here. So it's going to go in this direction, starting from the starting point to the end point. Okay? It's going to be vector EB. Okay, so what I did there was I actually drew a parallelogram. So vector EB is my answer to the first question. Okay, the rest get a little bit easier. So next we're doing CD minus BD. So that becomes CD plus negative BD. So CD, and then BD is actually in this direction here, but we're not going to draw it like that because it's minus, right? So we're going to draw it in this direction here, which works out nicely because now they're already drawn head to tail. I've got CD minus or plus negative BD. So it's actually nice. I can now draw my resultant from the starting point to my end point. So my resultant is vector CB. Okay, and the last one for this question. AB minus DB. So DB would normally go in this direction, but we're going to add the negative version of that. Okay? So we're going to go in the opposite direction. And nice, it's already drawn head to tail right there. So my resultant goes from my starting point to my end point. Therefore, my resultant is vector AD. Okay, so fairly straightforward. We're going to complicate things a little bit, okay, and not overly complicated, but we're going to calculate the magnitude and direction here of F1 and F2. The only difference is here, they're actually giving us the resultant, F1 plus F2. They're finding the sum. They're giving us the sum already, which is the resultant, and they're giving us F2. We need to now find F1. Okay, so not too bad. Now, finding the magnitude here isn't going to be difficult. It's finding the direction, and I'll explain why. Okay, so let's draw F2, 60 newtons, north 52 degrees west. So north 52 degrees west would be somewhere right about there, let's say. Okay, that's 60 newtons. Okay, and this is a 52-degree angle. Okay, and we've got F1 plus F2 is 75 newtons. F1 plus F2 is 75 newtons on a quadrant bearing south 85 west. So south 85 towards the west is going to be pretty close to the x-axis here. And it's 75 newtons, so it's slightly bigger than my other vector that's drawn. Okay? So this here is 85 degrees. Okay. And it is 75 newtons. So it's safe to say that we can now find this angle here. Okay? Because these three angles in here are going to add up to 180. So if I take, and let's call this something in a second. Let me just close off my triangle. This is where F1 is. Okay, that's where F1 is. So we have F2. Now remember, F1, okay, F1 needs to be drawn. Now this needs to be drawn head to tail, right? So F1 comes first. F1 comes first. So we're going to find F1, which we can do, okay? And then the angle that I'm going to need to find, so this is going in this direction here. Okay, F1 comes first, then F2, okay? And then our sum goes in this direction here. So we are going to find this, well, first we're going to have to find this angle, of course, but we're going to really, the angle we're going to report on starts on the north line because we're going to report it as a quadrant bearing, all right, a quadrant bearing. Or, I mean, we'll keep it as a quadrant bearing, actually, just because here they've given us quadrant bearings. Okay, so we need a game plane here. We need to find this angle here. Let's call it theta, this angle right there. Theta is going to equal 180. Those three angles should all add up to 180. Minus 52 minus 85. All right, so 180 minus 52 minus 85. And you should get an angle of 43 degrees. So theta is 43 in here. Okay, so if that's 43, I now have a contained angle here. I have a side, angle, side. Okay, so I can use the cosine law. Now I need to label this triangle here. Let's call this point A, point B, and point C, which makes F1 little a, this is little c, and this is little b. Okay, so here is my, I am finding side A, or F1. I'm going to call it A right now, and then set it equal to F1. So I'm finding A squared. I want that on my left. B squared minus C squared minus 2BC times the cos of capital A, or my 43 degrees. Fill in all your values. Sorry, that should say plus. Okay. So now you want to pull out your calculator and just double check, make sure that we have everything right. I put B and C in the opposite order, but that doesn't matter. It's irrelevant. You're still going to get the same answer. Okay. Again, we have contained angles, so we can use the cosine law. So there's my B squared, my A squared, or sorry, my C squared, my B squared and my C squared there. And I'm going to just calculate 75 squared plus 60 squared, which is 9,225. Bring down my minus sign and do 2 times 75 times 60 times the cosine of 43. And here you want to carry probably around 4 decimal places just to improve your accuracy. Okay, now take that value, subtract it from 9225, and you will get what a squared equals, which is 2,642.8167. Take the square root, okay, and you end up with 51. Now in the question, they didn't say how much to round to, and since we have just rounding to the nearest whole or just whole numbers here in the question, I'm going to round to the nearest whole here and say that we have 51 newtons. Okay, so therefore F1 is equal to 51 newtons. But we don't know the direction, do we? We don't know the direction. How exactly can we figure out? I mean, I know I can figure out this angle, capital B, like inside the triangle. But how can I calculate this little angle here, right there, right? Because I need to add that to it as well. Okay, so how can I go about to do this? Well, let's first find angle B, and then we'll try to use some geometry here, some of our angle theorems, to figure out what that little angle could be. Okay, we'll try to do that. So, angle B. All right, we're going to use the sine law. We have a full angle and opposite side. We know that one, which means I now have a opposite side, and I can find this angle here. Okay, so sine of capital B is over little b is equal to sine of capital A over little a. Fill in all your values. Little b was 60. Sine of capital A was sine of 43 degrees. Okay, over 51. Okay, cross multiply everything. You're going to end up getting sine of B is equal to 60 times sine 43 divided by 51. And then we're going to take the sine inverse of that. So 60 times sine 43 divided by 51. .8024. Okay? Which is 53 degrees. All right, so we got 53 degrees, which is angle B. Now, looking at this, you might feel stuck on how to find that small angle. But in reviewing this and really going back over our angle theorems or F patterns or Z patterns, what you hopefully can see here, and I'm going to highlight. Let's make that a little bit wider. What you can hopefully see is what's known as the Z pattern. So this 85 degrees right here, okay, is equal to this whole 85 degrees right there. So we actually didn't even need to find B in this case. Our Z pattern actually revealed the entire angle to us where we didn't even have to find angle B. Now, some of the questions you do have to find that angle, so you do want to get in that mind frame that it's possible. But in this particular question, we didn't even have to. We actually know now from the north line, here's our north line, and I know this is getting a little bit sloppy in here, that this whole angle in here is 85 degrees because of the Z pattern. So this is 51 newtons, right? 51 newtons, and we are going north from the north line, 85 degrees towards the east. And there is your F1 vector. So from the north line, look at what we have here, right? And I know it's kind of hard to tell in that diagram, but we have an 85 degree right here, okay, where my F1 is. So it's north going towards the east, north 85 degrees east. Okay, let's move on to the second question, which is very similar. And what I'll do, rather than just solving it, I'll let you solve it. We will set it up together. Okay, we'll draw this out, we'll set it up. So we've got F2 is equal to 20 newtons on a bearing of 65 degrees. Okay, so let's draw that first. F2 is 20 newtons on a bearing of 65. So 65, remember you're starting from the north line. And we're obviously going more than 45 here. And I'll draw my 20 newtons, maybe something along the lines of this. Okay. The sum, F1 plus F2, is 40 newtons. Sum is 40 newtons. Okay? So, and that's on a bearing of 89. A bearing of 89. So, and actually, again, that starts from the north line. That's basically 90, right? So I'm essentially almost drawing a right angle here. I'm so close. And it's 40 newtons, so it's double the length of my first vector that I drew. Okay? It's double the length. Now remember, this is F2. And actually, I probably shouldn't put my arrow here. Okay? I'm going to erase that. We'll figure out what the arrow is in a second. Okay, so that means my F1 must close this triangle off, so it's doing something like this. Now remember, we need to draw this head to tail. So F1 must go in this direction, because it's got to go head to tail with F2. So F2 goes like this, which means the resultant goes from the starting point to the end point. This is our starting point here. Oh, and by the way, this was 40 newtons. And this whole angle in here was 89, which means in this triangle here, this part of the angle right here was 24 degrees, right? 89 minus 65. 89 minus 65. Okay. So what do we have here? Well, we have a contained angle in here. So if I want to find F1, I have side, angle, side. So I can use cosine law. Once again, let's label our triangle. A, B, C, little a, little b, and little c. So we're going to solve for a, and that's going to give us F1, right? And to find our angle here, our direction, the direction here that I need to find for F1 starts on the north line and goes to here. That's the direction that I need when describing my F1 vector. Okay, so what's the game plan here in order to get that? What is my game plan? Okay, so here's the plan. What we have here, in order to get that angle, okay, you can see that I need to start just making Z patterns somewhere. And what I see is that with a Z pattern, I know that this is 65 degrees, okay? And this angle here, the angle that I'm looking for, is going to equal the same as this angle here. So once I find little a, if I can calculate this whole angle here, then subtract it from 65, or take 65 and subtract it from that big angle that I'm going to find eventually using the sine law, that's going to give me this little angle here. I'll just call it theta right now. And I know that that angle will be the same as that angle because of the Z pattern. So game plan here. We're going to find A, right? You're finding A using cosine law, right? Because you have a contained angle. Now to find our bearing angle, okay, so to find, our quadrant bearing, we are going to find angle B, okay? We are going to subtract 65 from angle B, and then use the Z pattern to find theta right there. Okay, so that's the game plan, and I want you to try and solve that. So start off by just doing the cosine law to find side A, which is our force, our F1, and you can go from there.